In this video, we'll explore how to determine the general term of a geometric sequence when we're given limited information. The information we're given in this particular question is that the fifth term, T5, equals 45, and the ninth term, T9, equals 720. What we're asked to do is find the general term and find T20, the 20th term. Well, we're going to be thinking a lot about the general term formula that geometric sequences use, which is Tn equals A times R to the n minus 1. And we'll use that to start off here. That is, we know T5 then will equal whatever A is, which we don't know yet, times R, which we also don't know yet. But for T5, we know n is going to be 5, so we get 5 minus 1. And we know what T5 is. We're told in the question T5 is 45. So we get our first equation, 45 equals A times R to the power of 4. Let's call that equation 1. Similarly, we'll develop equation 2. From T9 equals 720, we get T9 equals A times R to the n minus 1, where n is 9. So T9, which is now 720, equals A times R to the 9 minus 1 is R to the power of 8. Now let's call that equation 2. Now, very similar to what you did in grade 10, we're going to use a form of elimination, except since this is a geometric sequence, we're going to use elimination by dividing. That is, we can't subtract equation 1 from equation 2. I mean, we could subtract it, but we won't get any closer to the answer. What we're going to do is take equation 2 and divide it by equation 1. So let's see how that plays out. 720 equals A times R to the power of 8, equation 1. Equation 2, 45 equals A times R to the power of 4, equation 2. And I divide, that's a plus sign. And I divide, and I'll put a little circle around it. That circle just reminds me divide each thing. So 720 divided by 45, and I get 16. And here's the great part. Just like when we were subtracting in grade 10 and adding, we could cancel out terms. Here, the whole point of dividing is that you get A divided by A. What's any number divided by itself? Just a 1. And now the A's are gone. We're just going to be left with R's, and we'll be able to find them. The other rule you need to know about dividing is when you're dividing same base, you subtract the exponents. So I have R to the power of 8 divided by R to the power of 4. I subtract the exponents. 8 take away 4 is 4. So I'm left with 16 equals R to the power of 4. How do I get rid of a power of 4? I take the fourth root. But because it's an even power, when I take the fourth root, I need to take the plus minus thing. I'm going to get two possible answers. In other words, something times something times something times something 4 times. It could be a positive number that makes to 16, or it could be a negative because all the negatives will cancel out. If you can't see the answer directly in your head, you can use your calculator and ask it, what's the fourth root? So usually 4 and then shift your exponent button. 16 equals, fourth root of 16 is 2. But plus or minus 2. It could have been 4 positive 2's to make 16. It could have been 4 negative 2's to make 16. I have two possible answers, R equals 2 or R equals negative 2. So I'm going to sub them in separately. Let's try subbing R equals 2 into equation 1. That is, I already know R, I want to find A. So I'm going to pick one of my R's. I'll start with the positive R equals 2, sub it in. Let's pick equation 1, say, and I get 45 equals A times 2 the power of 4. And I'm going to solve for A. I get 45 equals A times 16. Running out of room a little bit. I want to get A by itself. It's A times 16. So how do I get rid of times? Divide. So I'm going to divide both sides by 16. I might just be able to fit it. And what's 45 divided by 16? 2.8125. Don't need a rounding dot because I didn't round. I get 2.8125. I'm going to do the same thing with R equals negative 2. I'm going to sub that in. Let's say sub R equals negative 2. I can use equation 1 again. It doesn't matter which equation you use. So I get 45 equals a times negative 2 to the power of 4. When you do negative 2 to the power of 4, that whole negative becomes powered as well. And so negative 2 to the power of 4 also gives me positive 16. So we're going to get the same answer, because we're going to get rid of this times 16 by dividing by 16. And so we get a equals, you can check it again if you want on your calculator, but it's the same math. 45 divided by 16 has to be the same thing, 2.8125. So what does that mean for us? It means that we have two possible answers. So therefore, our general term, our equation, the first part of this question was find the general term. So the general term is Tn equals a 2.8125 times r, let's put it in brackets for good measure, which is 2 to the power of n minus 1, or we don't know which one it is, it could be either, 2.8125 times negative 2. It's one of those two. One of these two formulas generated these two terms. We could check by subbing in T5, and we'd get the same thing for using either of these formulas. Same thing if you check for subbing in T9, you'd get the same thing. But we're not quite done. We want to find T20. So let's try one of our formulas to find T20. Now it's just a simple case of subbing in, but we want to check both formulas. Again, we don't know which one, either one of those, could have produced this possibility. So T20 could be one of two things. Let's sub in here. 2.8125, finding T20, so that's 2 to the power of 20 minus 1. So we get 2.8125 times 2 to the power of 19. And from there on in, it's going to be calculator. 2 to the power of 19 times 2.8125. And I get 1,474,560. That's assuming the R was positive. Again, two possibilities. Let's check the other one. If we're using our other possibility where R was negative, we have T equals 2.8125 times negative 2 to the power of 20 minus 1. So T20 equals 2.8125 times negative 2 to the power of 19. So we'll recalculate that, and we'll go with brackets, negative 2. Didn't really need the brackets, I just want to make sure my calculator does the whole negative to the power of 19, and that's because the answer should end up negative. We have an odd number of negatives being multiplied together in this exponent, so you get negative times 2.8125, and as you might have expected or knew, we get T20 equals negative 1,474,560. So we have two possible answers for what T20 could be. This is a nice example of how to determine the general term of a geometric sequence given limited information, and in particular here, this particular question had two possible general terms because there were two possible ratios or two possible R values.